Hey there. Every time you've played a game, logged into an app, or just browsed a website, that program is juggling a ton of information behind the scenes. But how does it keep track of it all? Well, today, we're going to peel back the curtain and look at the absolute fundamental building blocks that make it all happen: variables and data types in Java.
Okay, so let's kick things off with a really basic problem that every single program has to solve. Think about it. When you level up in a game or you change your profile picture, how does the computer actually remember that new info for later? What's going on under the hood?
And here's the answer. And it's actually a beautifully simple idea. The computer uses something called a variable. Honestly, the best way to picture a variable is exactly like this, a labeled box. The label on the outside, that's the variable's name, like my score. And whatever you put inside the box, say the number 100, that's its value. It's really that straightforward.
So if we're going to get a little more technical for a second, a variable is just a named spot in the computer's memory that we've reserved to hold some data. It's like our own little labeled container in the huge warehouse of computer memory.
So we've got our labeled boxes, right? The next logical question is, what kind of stuff can we actually put inside them? Can you just throw anything you want in there?
Well, in Java, everything you can store is organized into two big families. On one side, you have your primitive types. These are the simple, really fundamental building blocks. And on the other side, you've got non-primitive types, like strings and arrays, which are kind of like more complex, custom-built containers.
For right now, we're just going to zero in on the primitives. You've got to master these first, because pretty much everything else in the language is built on top of them. The good news is there are only 8 of them, so let's get to know them.
Now what's interesting here is that not all boxes are the same size. An int, for example, is your go-to box for whole numbers. Think a player's score or maybe your age. A double is a bigger box designed for numbers with decimal points, perfect for something precise like the price of an item. And then you have Boolean, which is the simplest box of all. It can only hold one of two things, true or false. That's it. Perfect for things like, is the user logged in? Yes or no?
Okay, so we've got our boxes, and we know what kind of stuff can go inside. But what about the labels? I mean, just like in the real world, you can't just slap any old label on there and expect things to work. There are rules to keep everything organized.
And these are the non-negotiables, the hard and fast rules. Your variable names can have letters and numbers, but they absolutely cannot start with a number. They're also case-sensitive, which means my score with a lowercase m is a totally different variable than my score with a capital M. And of course, you can't use words that Java has already claimed for itself, like class or int.
Now, beyond the strict rules, there are conventions. Think of these as the good habits that professional developers use to make code easy for other humans to read. The big one is camelCase. See how the name kind of looks like the humps of a camel? The first word is all lowercase, and then every word after that starts with a capital letter. It just makes long names like player final score so much easier to read at a glance.
So, we've talked about numbers and we've talked about true or false values. But what about text? Like a username or a message in a chat window. This is such a common type of data that it gets its own special kind of box.
In Java, a piece of text is called a string, and it's really just a sequence of characters. Now, here's a key thing you have to get used to in programming. Computers start counting from 0. So in the string hello, the H isn't at position 1, it's at position 0. The E is at 1, L is at 2, and so on. This is called zero-based indexing, and you'll see it everywhere.
And check this out. Here's a really clever trick Java uses to save memory. If you create two different variables, but they have the exact same string value like ABC, Java doesn't waste space by creating two identical strings. Instead, it puts one ABC in a special place called the string pool and just has both of your variables point to that one spot. Super efficient. Now, because of that string pool trick, we have to talk about something that trips up almost every new programmer. If you use two equal signs, double equals, to compare strings, you're not asking if they have the same letters. You're asking, are these two variables pointing to the exact same spot in memory? What you usually want to ask is, do the contents of these two boxes match? And for that, you almost always need to use the dot equals method. It's a crucial difference.
All right, you've got the fundamentals down pat. Now let's level up and look at a couple of pro tips that give you even more control over the data inside your variables.
So sometimes you'll have data in one type of box, but you need to treat it as another type. For instance, maybe you've calculated an average score of 97.8, but you just need the whole number, 97. This process of converting from one type to another is called typecasting.
Let's go back to our box metaphor. Widening is like moving an item from a small shoebox into a giant storage container. It's going to fit, no problem. So Java does this for you automatically. But narrowing, well, that's like trying to shove that giant item back into the tiny shoebox. It probably won't fit. You have to manually tell Java, hey, I know what I'm doing, and you accept the risk that some of the data, like the decimal part of a number, might get sliced off and lost forever. Now for one of the golden rules about strings in Java. You have to remember this one. They are immutable. It's a fancy word, but all it means is that once a string is created, it can never be changed. This is actually a massive feature for writing safe and predictable code. It means if you have a piece of text, like a password or a configuration setting, you can be 100% sure it won't be accidentally modified somewhere else in your program.
So what does immutable really mean in practice? Let's walk through it. Say you create a string that says hello. Then you call a function to make it uppercase. Here's the twist. Java doesn't go back and change your original string. Nope. Instead, it creates a brand new string object that contains hello and hands that back to you. Your original hello is left completely untouched, safe and sound.
And speaking of functions, strings come with this amazing built-in toolkit of methods. You can instantly get the length of a string, convert it all to uppercase or lowercase, check if it contains a specific word, or even slice out just a small piece of it. These tools make working with text incredibly powerful and flexible.
So when you put it all together, you can see that variables, data types, and strings, they aren't just abstract ideas. They are the fundamental Lego bricks of programming. They are the boxes you use to hold the score, the username, the chat message, the price, literally everything that makes a program feel alive. You now have the building blocks. The only question left is, what are you going to create with it?